cryptographic algorithms. Okay, we have different cryptographic algorithms in that MD algorithms and the SHA algorithms, Wolfpool algorithms. Okay, so in this we are going to discuss first about the MD. So what is the MD? Means message digest. Okay, message digest algorithm. So this message digest algorithm was designed by the Ronald Rivet. Okay. Okay. This algorithm was designed by the Ronald Rivet in the 1991. Okay, so in this algorithm, it will give the 128 bits as a digest. Okay, so it will give 128 bits digest means output. So in the starting only we told it will give the fixed size output. So whenever you are using the message digest algorithm for generating the hash values, the size of the digest is 128 bits. Okay, now we'll see MD5 deeply. Okay, now we'll see the message digest. So first one is so what are the steps whenever we are using this MD5 MD algorithm? What are the steps we have to see? So here the 5 steps are there. First one is append padding bits, append 64 bits representation, and initialize MD buffers. And the fourth one is a process the each block. Okay, next generating the output. So these are the different steps in the MD5 algorithm. First, append padding bits. Okay, first we will see the step by step. So the first step is appending the padding bits. Okay, so here first what we have to do, we have to add some bits. Okay, we have to add some bits to the original message. Okay, so here it is my original message, and here what we have to add some bits. Okay, so here we have to see how many bits we have to add. Okay, how many bits we have to add. So here a padding is done such that the total length is 64 less than the exact multiple of 512. Okay, so here how many bits we have to add means, so if after adding the padding bits, the total length, okay, the total length is a 64 bit less than exact multiple of 512. Okay, suppose my uh, my message size is 1000 bits. Okay, so here how many bits we have to add, we have to see. First we will see the 5 multiples. Okay, the 512 multiples. So the 512 second multiple, if you are multiplying, then 1024. Okay, so it is not 64 less than my original bits. So suppose if you are subtracting this 1024 from if you are subtracting this 1000 from 1024 bits, then we'll get 24, but it is not less than the 64. Now try with the second multiple. Okay, third multiple, 512 into 3, so we will get 1556. Now you have to say, if you are subtracting 64 bit, then we'll get the 1472. So my so here we have to check my original message bit size is 1000 bits. Here I need to get this one. So this is 64 less than the 512 multiple. I have already 1000 bits. Okay, to get this one, how much we have to add? We have to add 472. Okay, so these many bits we have to add to the original message. So that is a padding. So here for this example, 412 bits we have to add. Okay, so this is padding. Okay, so the first one is appending padding bits. So here padding bits means like how many bits. So here where we have to add at the end of the original message, we have to add this here. Okay, so that is, it should, padding bits should be start with 1 and remaining are zeros. So that is 1, and then remaining 471 0 bits, like that you have to add. Then the total length is less than 64 bits. Okay, less than the 64 bits of the 5 multiple. Okay, so that one. Next, the second step is appending the length. What we have to second. Okay, how append the original length padding bits. So okay, what we have to append. So here what is the 64 bits? So that 64 bits is the uh, that 64 bits are my, what we have to express my message into 64 bit representation. That's bits we have to add here. Okay, so that is the second. Okay, so here in the second step, what we are doing, we are representing my original message in 64 bit format. That format, sorry, that bits we are adding to the previous one. So now this total length, okay, total length is 6. The total length is, if you are doing this one, then it should be divided with 64. So like that we have to add padding bits. Next, the third step,